Hello mga ka-CH! Welcome back to another episode of Curiosity Homes, where your curiosity is the limit. Today, we're going to discuss two methods of assessing your ABG. What is ABG? ABG stands for arterial blood gases. It is a test to evaluate the lung gas exchange. It means that it assesses the ability of your lungs to adequately provide oxygen and remove carbon dioxide, which reflects ventilation, and the ability of your kidney to remove and reabsorb bicarbonates, which reflects metabolic status. In short, ABG is a test that analyze or that examine the acidity and alkalinity of your blood. Because ABG only evaluates arterial blood gases, the site of withdrawing blood samples for ABG are as follows. We have your brachial area artery, we have your radial and ulnar artery. Take note when we try to get ABG samples from radial and ulnar artery, we need to do first Allen's test to test the adequacy of blood flow between those two arteries. We have femoral artery. Sometimes we can get ABG samples from central access line via your subclavian artery. So how can we analyze ABG? The first thing to do is we need to memorize and master the normal values and components of ABG. We have pH as components of your ABG analysis. pH only determines the acidity and alkalinity of your blood. The normal value of this one is regulated at another range of 7.35 to 7.45. Means that anything that is less than 7.35 is considered as acidic or acidosis. Anything that is more than 7.45 is considered basic or alkaline or alkalosis. Why it is necessary to evaluate the blood pH levels or any disturbances of the blood pH in our blood can affect the metabolic processes in our body, especially the enzyme actions. And any deviation more than the critical point is always fatal. Next, we have your PaCO2 or your partial pressure of arterial carbon dioxide. The normal value for this one is 35 to 45 millimeter mercury, and it is easy to memorize this one because we can see it in the value of your pH, which is 7.35 to 7.45. So somehow it it will help you to memorize the PaCO2 value, which is 35 to 45 millimeter mercury. So I want you to associate the PaCO2 values to acid, because PaCO2 means the amount of carbon dioxide in your arterial blood. So the more carbon dioxide in your arterial blood, it will make your blood more acidic. Why? Because if your carbon dioxide mixes with your arterial blood plasma, it will be converted into carbonic acid. So carbonic acid is a weak acid, but if you have more of it in your blood, it will make your blood more acidic, as for it will disturb the normal blood pH. And your PaCO2 levels is being regulated by your respiratory system. Next, we have your HCO3 or bicarbonate. Its normal value range from 22 to 26 milliequivalent per liter. So I want you to associate the bicarbonate level to alkaline or base, because the more bicarbonate in your blood, it will make your blood more alkaline, in a more alkalotic, And if there is a less bicarbonate level in your blood, it will make your blood more acidic because HCO3 can increase the pH value of your, or the pH level of your blood. Okay, and it is regulated with your by your kidney. Next, we have your PaO2 or partial pressure of arterial oxygen. The normal range is from 80 to 100%. Although PaO2 is not necessarily important, it's not included when we try to analyze ABG, but if we try to know if our patient is having hypoxia, now we look at the PaO2 values. But for the sake of ABG analysis, we just use the three components of ABG, which is pH, PaCO2 or your partial pressure of arterial carbon dioxide, the HCO3 or your bicarbonate. So as you can see here, anything that is less than 7.35 in your pH is considered acidic. Anything that is more than 7.45 is considered alkaline. With your PaCO2 or the amount of carbon dioxide in your arterial blood, anything that is more than 45 millimeter mercury is associated with acidic state. If you have less than 35 millimeter mercury, it is associated with alkaline or alkalotic state. Now we have your bicarbonate. So remember, as what I told you a while ago, that bicarbonate is related to alkaline. So the higher the bicarbonate, the more alkaline your blood will be. So if you have a value that's more than 26, it means that your blood tend to become alkalotic, or you will have alkalosis. Next, if it is less than 22 or 21 and below, it will make your blood more acidotic or acidosis. There are many ways of analyzing ABG, but for the sake of this video, we are just utilizing two methods. We have the Rome method, or a short for respiratory opposite or metabolic equal. So it means that we will treat any conditions in the ABG result if it has an opposite arrow. We try to analyze it as respiratory. It has, if the arrow are the same or equal, it always mean metabolic. But in the concept method, we try to look at we try to analyze by relating to PaCO2, or any disturbances of PaCO2 is related to respiratory problem, and any disturbances to HCO3 or bicarbonate is related to metabolic problem. The start of this discussion, let's gonna use Rome method. So in the Rome method, we just need to identify if the value of the ABG is increasing or going up, or decreasing or going down. For example, your pH, is the value of your pH increasing or decreasing? With your PaCO2, is it increasing or decreasing? In your bicarbonate, is it increasing or decreasing? Always remember, when we try to analyze the ABG result using your Rome method, always remember any value that is opposite. So for example of this one, if your value of your pH is increasing and then the value of your bicarbonate is decreasing, always look at the respiratory as the primary acid-base disturbances. But if you have a equal, or the same arrow, or the same disturbances of your pH and bicarbonate, for example, if you have here increasing pH and your bicarbonate is also increasing, so always look at that one as a metabolic primary acid base imbalances. Okay, so now let's try to look at this one. So pH value of 7.3, is it acidosis or alkalosis? So remember, the normal value for your pH is 7.35 to 7.45. So it means that 7.30 is acidic, so it is going down. So let's put an arrow here, going down. Next, we have your PaCO2 level. So what is the normal value for your PaCO2 level? Yes, it is 35 to 45. So in this case, this is normal. Next, we have your bicarbonate level, 20. So in your bicarbonate level, the normal value is 22 to 26. So your 20 here, this is increasing or decreasing? This is decreasing. Because the arrow is the same, so we will analyze this ABG result as metabolic. Acid or base, so this is, we conclude that this is acid. And try to look at the bicarbonates, so it has the same arrow, so we can analyze this one as metabolic acidosis. Metabolic is because you have the same arrow going down, and this is as acidic or acidosis, so that's why this is metabolic acidosis. So let's have another example. pH of 7.31, increasing or decreasing? This is decreasing. It means acidosis or acidic. Bicarbonates of PaCO2 of 35 is normal, and ACO3 of 20 is decreasing also because the normal value is 22 to 26. So we can interpret this one as metabolic acidosis. Metabolic because metabolic equal means the arrow is equal or go the same. This is metabolic acidosis. How about this one? pH level of 7.45. Is it increasing or decreasing? So it is increasing. Let's put an arrow here, increasing. When it is increasing, it means that this is alkalosis or alkalotic. Okay, this means alkaline. So because the normal value is 7.45. Next, PaCO2 of 30. The normal value is 35 to 45. So this is increasing or decreasing? This is decreasing. Okay? Mababa siya. Next, we have bicarbonate level of 29. It is increasing or decreasing? Okay, you're right. It is increasing because the normal value is 22 to 26. So as you can see, the arrow of pH level and bicarbonate is the same, going up. So let's treat this one as metabolic. And what is the acid-base disturbances? The primary acid-base disturbances, it is 7.45, which means alkalotic. So this is, we interpret this one as metabolic alkalosis. Next, we have 7.30. Is it increasing or decreasing? Decreasing, it means acid. We have your PaCO2 of 50. The normal value is 35 to 45. This is increasing, which means it's related to acidic state. Next, we have your bicarbonate level of 30. Is it increasing or decreasing? This is increasing. So remember, when we have an opposite arrow, always treat as respiratory. So your bicarbonate level is increasing, your pH value is decreasing, treat is this one as respiratory. But because of your pH level 7.3, it is acidic, so let's interpret this one as respiratory acidosis. How about this one? pH level of 7.48. Is it increasing or decreasing? This is increasing. It means alkalosis. How about the PaCO2 level? 30. It is increasing or decreasing? This is decreasing. Okay? How about the bicarbonate level? HCO3. 21. Is it increasing or decreasing? This is decreasing. So look at the pH level, the arrow of your pH increasing, and the bicarbonate arrow is decreasing. So this is what we call a respiratory because it is opposite. And try to look at the pH. This is alkalosis, so this is respiratory alkalosis. So you just need to look at the pH and the bicarbonate. So the arrow is the same, either increasing or decreasing. It is always metabolic. If the arrow is opposite, either the bicarbonate is increasing or the pH is increasing. But if you can see that the pH and the bicarbonate has an opposite direction of your values, so it is what we call a respiratory. Okay? So now let's analyze compensation using the Rome method. So first we look at the value of your pH. Is it increasing or decreasing? This is decreasing, means acidosis. The PaCO2 50, it is increasing or decreasing? This is increasing. The bicarbonate level of 30, this is also increasing. So in your Rome method, it is stated there that compensation is, we can analyze compensation if the value of your PaCO2 and the bicarbonates has an arrow of this, has the same arrow. It means, for example, this one, we can assess that the arrow of your PaCO2 is increasing, and also the arrow of your bicarbonate is also increasing. So we are sure that in this ABG result there is a compensation is happening. It's either going up or going down. If these two values has the same arrow, compensation is analyzed. So can analyze this one. A respiratory acidosis is because we can, when we try to look at the arrow, we try to look at the arrow. This one is has an opposite arrow, the bicarbonate and the pH. So the respiratory opposite, so we have an opposite. This is a respiratory, and the pH level is 7.30, which is acidosis. That's why we interpret this one as acidosis. Is there a compensation? Yes, there is a compensation because we can assess two arrows. We have the same arrow of PaCO2 and the bicarbonates. We have the same two up. This is we can assess that there is a compensation. But may I ask, is it partial or complete? If the value of your pH, we can assess if the compensation is complete or partial by looking at the pH. So here in our example, the pH is 7.30. It means the compensation is not enough to bring back the pH level into the normal values. So we can assess that this is a partial compensation. Okay, so let's have another example. So we have pH of 7.30, same. This is decreasing, which is acidosis, and the PaCO2 of 50, it is also increasing, and the bicarbonate level of normal. So we try to analyze if this is acidosis or alkalosis. This is acidosis because this is 7.0. The arrow is going down, and we try if the bicarbonate level is normal. We look at the PaCO2 level. So the PaCO2 level is increasing, so it means it has an arrow that is up, going up. So we can identify that this is a respiratory opposite. So this is an opposite arrows. This is a respiratory, not metabolic. But according to the modules, our modules, if the PaCO2 and bicarbonate doesn't have the same arrow, which in this area the HCO3 is normal, so we can it is not the same with the PaCO2, so we can conclude that there is no compensation. Okay, so this is what we call respiratory acidosis. Respiratory acidosis because we have an opposite arrow here. Now, if the bicarbonate is normal, we can look at the PaCO2. We have an opposite arrow. This is a respiratory acidosis because the pH level is 0.30, which is it means acidotic state. So this is acidosis. Is there a compensation? No compensation because we cannot see that the HCO3 level is also increasing. Compensation only can be assessed if there is the value of this one or this one would increase or decrease at the same way. So this is what we call respiratory acidosis uncompensated. Let's try this another example. 7.48, it is increasing and also means alkalosis. PaCO2 of 30, this is also decreasing or increasing. This is decreasing, which means there's less carbon dioxide, which means alkalosis. And a bicarbonate of 21, which means also decreasing, which means there is an acidosis, could be acidosis. But when we try to analyze this one using the Rome method, so look at the pH value, alkalosis, and the arrow is increasing, and then bicarbonates is decreasing also. So we can analyze this one as respiratory and then alkalosis. Next question, is there compensation? Yes, there is compensation because the arrow of PaCO2 and the HCO3 are the same, so going down. So it means there is a compensation. The question is, this is complete or incomplete? And you can analyze if it is complete or incomplete by looking at the pH. Is the pH normal? If it is normal, so we can conclude that is a complete compensation. But in this case, this is abnormal. So it means that the compensation of our body is not enough to bring back down the pH level into the normal values. So this is what we call a respiratory alkalosis partial compensation. Partial compensation because the pH level is not within the normal values. Okay, next. For example, this one pH level of 7.45, so it means there is compensation there because the pH is normal. PaCO2 30, this is decreasing, and SCO3 level 21, this is also decreasing. So the problem of the Rome method, because the pH level is normal, we cannot identify if this is respiratory or metabolic primary problem, because we cannot identify the pH as compared to the other values, or there is no arrow there. So that's why we need to use the next method, the concept method. So in concept method, we can analyze compensation by first is knowing your patient. So what does it mean? For example, with this ABG result, if the patient is being admitted because of respiratory problem, so I could analyze this one as respiratory alkalosis. Because my patient is having a respiratory problem, so this is a respiratory alkalosis. Okay, because we are now looking at the concept of respiratory. If the admitting diagnosis of patient because of diabetic ketoacidosis, I would assess this one as metabolic acidosis complete compensation, because we are now focusing into the metabolic part of the ABG analysis, which is the HCO3, means metabolic, not the PaCO2. So it means that the decrease of PaCO2 in case of your patient of ketoacidosis, it is the compensation, means the respiratory system compensate by decreasing the carbon dioxide in order to bring down the pH level into the normal level. So that is by using your pH, you're knowing the patient diagnosis. So what if in the board exam or presenting an ABG without patient diagnosis? So that's why we have a next concept method analysis of acidic side or alkalotic side. So what does it mean? So it means that in your pH level, we have the normal value. We had a 7.35 to 7.45. So it means that 7.40 is in a neutral point or neutral value of your normal pH value. It means that values from 7.35 to 7.39, it is what we call the normal acidic. Although it's a normal acidic, normal pH value, but it is more onto the acidic side. Okay, remember that one. Next, so we have your uh, normal alkalotic side. So if ever you have a value of your pH from 7.41 to 7.45, that's what we call the normal alkalotic side. So although it is normal, but it's leaning toward alkalotic side. So how could we apply this concept method to analyze there is compensation if there is no diagnosis? So first is we need to know if there is acidosis or alkalosis. So as you can see, this is normal. So let's proceed to the next step, identifying if it is metabolic or if it's respiratory. In this case, guys, we can assess that this is in the alkalotic side. So if there is in this is in the alkalotic side, so it means the value that makes sense of this analysis is the PaCO3, because PaCO3 is less than 35. It is leaning more onto the alkalotic side. The right analysis of this one is respiratory alkalosis, and it is compensated by your bicarbonate by decreasing the bicarbonate level in order to counteract the alkalinity of the blood to bring back the pH level in the normal range. So that's it. So that's why our interpretation of this one, respiratory alkalosis, it's because uh, the pH level is leaning toward the alkalotic side, and the PaCO2 level is also leaning to alkalotic side, no? Because this is less than, so that's why respiratory alkalosis. And we have a complete compensation because of the pH is normal, so complete compensation. And the decrease of the bicarbonate here, this is the compensation. This is the reason why your pH level is being brought down to the normal level, which is 7.45, and that's explain why the ACO3 is decreasing. Let's have another example. So pH of 7.34, is it normal or abnormal? This is abnormal. This is acidosis going to the acidic side. Then PaCO3 CO2 of 19, is this normal or abnormal? This is abnormal, less than 35, going to alkalosis side. And how about the bicarbonates? This is less than 22, going to the acidic side. So we have here the pH is acidic and the bicarbonate is going to the acidic. So the cause of it, that the reason why the pH is become acidic is because of the bicarbonate. It decreases, it makes the pH blood pH level goes down. So we can conclude that this is metabolic acidosis. Okay, but is there compensation? Yes, there is compensation because the value of your PaCO2 is abnormal. It is below the normal value, which is 35 to 45. So the reason why the PaCO2 is decreasing, it's because it counteracts the blood pH level of 7.34. The next question, is it complete or partial? So as we can see, the pH level here is still abnormal. So that's why this is a partial compensation, because the decrease of PaCO2 level of 19 is not enough to bring back the pH level to its normal level, which is 7.35 to 7.45. What is the correct interpretation of this one? This is metabolic acidosis, partial compensation. Okay, next. We have a value here, a pH of 7.44. Is it normal or abnormal? This is normal because the normal value of your pH is 7.35 to 7.45. This is within normal, but using the concept method, this is going to the normal alkalotic side. Okay, alkalotic side. Next, look at the PaCO2. It is 49. So it is leading toward the acidic side because increase in PaCO2, which means it makes your blood acidic. And let's look at your bicarbonate. Bicarbonate is 30. The normal value is 22 to 26. So increase in bicarbonates, as what I told you before, it is related to alkaline or base. So it makes your blood more more alkaline. So the right interpretation of this one is metabolic alkalosis is because the pH is within the alkalotic side. So the reason why the pH is in the alkalotic side is because of the bicarbonate. Now, bicarbonate level, it is increasing. So the next question, is there compensation? Yes, there is a compensation because the value of your PaCO2 is abnormal. It is more than 45, it's 49. So the reason why the PaCO2 is increasing because it compensates with the decreasing amount of, or the increasing amount of your bicarbonates level that is causing the blood into becoming more alkalotic. So because the PaCO2 is increasing, that's why the pH is going back to its normal level, which is 7.44. So this is what we call complete compensation because the pH is normal. But we can analyze this one as metabolic alkalosis. It's because the pH level is leaning toward the alkalosis side, and the only thing that makes sense with the alkalotic condition is the bicarbonate. So this is the culprit, or this is the primary acid-base disturbances that causes the pH level to increase and become alkalosis. And compensation happens, that's why the PaCO2 is increasing. If the PaCO2 is within the normal range, so we can analyze this one as uncompensated. So it means your body does not respond or does not compensate to the increasing blood pH. Thank you for watching. I hope you learned something today. Don't forget, your curiosity is the limit.